Alright, hey guys, I'm going to try to do a quick explain everything for you so you can get some Cornell notes down today. I'm in the building, but I've got some DB registration meetings that I'm required to attend. So what I want you to do is go ahead and get your scientist notebook opened up and set up your Cornell notes. Go ahead and title it Acids and Bases. All right, now this is the learning target while you're doing that. This is the last chemistry unit that we have in 8th grade. So if you don't like chemistry, get ready, yay, you can be happy for a little bit. But the very last thing that we do is we do a discussion on the properties of acids and bases. And you notice it says basic properties. When we get into this, I want to be very clear with you. There are some different ways that we can define acids and bases, and in 8th grade we're just going to define it in the most elementary way possible. When you get to high school, you'll learn that there are some other ways that you can define these two things, and when you do that, that means that you'll see that there are some additional compounds that can be considered to be an acid or base. And you'll talk about those in high school and in college, but we're not going to talk about those types of things right now in 8th grade, okay? So we're just looking at a very basic general understanding for right now. All right, now I wouldn't take time to write all of these down. You can write a few of them down. I always like, before we get into a formal definition of what an acid is, I actually like to sort of let kids figure it out first. If I start you right out with the definition, it doesn't make any sense, or I don't think it does. So the first thing I do is just show you, hey, here's some common acids, and they're all compounds. You'll work with most of these at some time or another as you go into high school and college. I've not really ever worked with that oxalic acid thing down. Well, I think I did in college one time. But anyway, hydrochloric acid, sulfuric, nitric, carbonic, acetic acid, citric acid, found in orange juice, lemons. Phosphoric acid is found in soda pop. I drink enormous quantities of it every day. And then the oxalic acid. All right, so the first question I always ask kids is, let's look at these compounds. What do you notice that they all have in common? So Matthew Esplin, they do not all have moo 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 in common, but Matthew, can you tell us what they all have in common? See, that's me pausing and waiting. Okay, so I'm going to assume Matthew said something and he didn't say moo moo. They all have at least one hydrogen. So I want you to hang on to that. As you look at these, you can see that all of them have at least one hydrogen. A few of them have two, and phosphoric and citric actually have three, but they have at least one hydrogen as part of the compound. All right, so at this point, I had this really neat simulation, and I can't get it to work embedded in Explain Everything. So what I usually do is show you a really nice animation of some lovely hydrogen, some lovely water molecules, and the water molecules are hanging out. They look like Mickey Mouse. They're just all happy. And then all of a sudden you drop in some hydrochloric acid. And the hydrochloric acid, when it comes in there and you watch carefully, you notice something. What you notice is that the hydrogen breaks away from the hydrochloric acid, and you guys remember that that is just a simple HCl. So this hydrogen actually breaks apart from the chlorine, and it goes over and it hooks up to the H2O. And that is really cool, because then what happens is the H2O actually turns in to H3O, and it is an ion. You notice you've got your plus charge there, and that has a really unique name. That strange compound, that H3O, is called a hydronium ion. And we were really surprised, but we have actually seen that on the sample TCAP. They use the word hydronium ion to describe the H3O plus ion that is formed when an acid combines in water and the acid breaks apart and the hydrogen goes and hooks on to the water molecule. So your water molecule, instead of looking like Mickey Mouse, it looks like Mickey Mouse with 3 ears on it, and it's called the hydronium ion. So you are going to have to know that particular word for the TCAP test. So now you actually get to write something down. Knowing some of you, you've already been writing frantically, but with the exception of maybe writing a few of the examples down, this is really the first thing you should have in your notes. So we're ready to get our definition of an acid. All right, it's any compound that when you dissolve it in water increases the number of hydronium ions. Occasionally, we have kind of a shortcut way of writing that H3O plus. Sometimes you'll see people just write this. They'll just write an H plus. It's a shortcut, but what they really mean is it stands for the entire hydronium ion. So any compound that when you dissolve it in water increases the number of hydronium ions is going to be considered to be an acid. The hydrogen atom breaks away from the acid, combines with the water molecule, so instead of having the H2O, you have H3O plus. This didn't translate real well from my PowerPoint. That little arrow is supposed to be up here, I guess. There you go, I'll fix it. So here's an example, and this is the way that this would actually look. This is actually called an ionic equation, but you would have the HCl plus the water yields, and you notice we have a chlorine ion, and that's exactly what's going to happen. That chlorine is going to end up with a negative charge, plus we have our H3O plus. All right, so we've got our positive and our negative charge, and this is the way that it would be written. All right, so it's important for us to have some basic properties of acids. So I would put properties of acids over as your keyword on the left-hand side. They have a sour taste. Lemons, limes, the citric acid that is found in those types of fruits give you good indication of the sour taste. No, we are not going to go in the lab and taste hydrochloric acid. That would not be cool. Acids are poisonous. And they also do something that is really neat. They turn indicators specific colors. Now let me explain. An indicator is any chemical that changes color in the presence of an acid or a base. There are tons of different types of things that can be used as indicators in the chemistry lab. Everything from litmus to phenolphthalein to bromothiamyl blue, phenol red. We have a lot of different things. These are indicators, and they simply help chemists determine whether something is an acid or a base. The ones that we think that you will definitely want to know, the first one is bromothiamyl blue. If you look over on my desk, there is a little flask over there, and it actually has some bromothiamyl blue in there. And I'll show you this later, but you can take some acid, and yes, there's some hydrochloric acid on my desk, and don't touch it, but you can actually take the hydrochloric acid, and I'll do this for you tomorrow. You can add it to the bromothiamyl blue, and it'll change it to yellow. We also have some special paper that some of you may have already used in the past. This is called litmus paper, and it's coated with a chemical on it. And there's blue litmus paper and there's red litmus paper, and you'll be using that in the lab later this week. If you have some blue litmus paper, just like in this little picture here, and you put some acid on it, acids will turn blue litmus paper to red. So those are some initial properties of acids that we have. Now, I was hoping that this little computer program would actually let me play a little embedded video within the Explain Everything. It won't. So again, I'll do the little demonstrations and show you this tomorrow. I'm just more interested in having you at least get your notes down. Acids are corrosive. The word corrosive means basically that they will destroy things. They'll break things down. They'll melt your face off. And in this case, I have a little video clip. They take some little Hot Wheels car and they put it in some nitric acid, and you get to see the nitric acid basically be very corrosive to the Hot Wheels car. Remind me, though, I actually also have a fantastic video of putting some cheeseburger, a McDonald's cheeseburger, in some hydrochloric acid. Yeah, and you can watch and see what happens after a little bit of time in there. That's pretty interesting too. But anyway, acids are corrosive. You always want to be careful around them. This is the next property I want you to write down. Acids will react with certain metals, not all of them, but they will react with certain metals to give off hydrogen gas. And I found a little video clip on YouTube. You'll have to remind me, I'll show this to you tomorrow, of a chemistry teacher, and he wanted to do a demonstration for his kids, but it's just very unsafe. The kids are way too close to the guy. I don't think anybody has safety goggles on. But what he did is he just basically took some acid, reacted it with some zinc metal, and then he collects the hydrogen gas in a balloon. Ties the balloon off, lets the balloon go, floats up to the ceiling, and then he holds up a lit flame of some sort to the balloon because hydrogen gas is highly flammable, so he wants to show his kids, he's proven that it's really hydrogen gas that's been given off. That's fine and dandy. I'm sitting there thinking this guy's going to start his, ceiling on fire here. But anyway, I'll show you the video clip tomorrow. And again, I do have some zinc metal. I've got some in a test tube. I'll put some acid in it. And you can see the bubbles. You can see that the hydrogen gas is being created. But this is another property that you will be expected to know on your TCAP test. So another basic property, that acids will react with certain metals to produce hydrogen gas. Okay, so I just want to say that you will have to remind me, I have to show you that the cool video where we do put the McDonald's cheeseburger and the hydrochloric acid. So then, I don't know, I just found this picture and I stuck it in the PowerPoint, and then some kid said that I think it's actually, I don't know, I think it's from this bad it might be from Breaking Bad, I don't know. Then another kid said that, they might have maybe killed somebody and then they're getting rid of somebody, so I don't know, I probably should have skipped this, but it's in there, so too late now. Okay, so now we are on to the exciting world of bases, and I start kids out exact same way. If you want to, you can write a few of these down. Abby Nash, you do not have to write all this down. You can do a couple of them. And before I give you the definition of a base, I just say, all right, let's look at some of them. And so I've given you the name and the formulas of some common bases. You notice we've got lithium hydroxide, potassium hydroxide, cesium hydroxide, strontium hydroxide, sodium hydroxide, good old sodium hydroxide up here, rubidium hydroxide, calcium hydroxide, and barium hydroxide. And just the way the PowerPoint got converted in this, the two looks really weird, but they look like they're right beside each other. They're not. They're still subscripts. It just came out looking kind of odd in this Explain Everything software. All right, so I always go, okay, look, what do they all have in common? And I will call on someone. Let's see. I hope they're there today. Lindley. When you look at these, what do they all have that is the same? Here's my pause. All right, so I hope Lindley said they all have the word hydroxide. That's right. Or you notice that they all have this OH. See, there it is, there it is, there it is. So that's given you a big clue about what the definition of a base might be. All right, so the definition of a base, and this does need to be written down, it's any compound that increases the number of hydroxide ions. A hydroxide ion is OH with a negative there. You should remember oxygen is almost always -2, hydrogen's +1, so you can see that makes an ionic compound with a -1 charge. So if we have a compound, we dissolve it in water, and this is one basic definition, guys, of a base. Have a compound, we dissolve it in water. If that compound breaks apart, if it breaks apart and it increases the number of hydroxide ions, then we will call that a base. So you notice just in our most basic one, there's our sodium hydroxide. I mean, basically what I'm saying is that if I put this in water, this thing is going to break apart, and what it's going to do is it's going to break into this. You're going to end up with a positively charged sodium ion. This OH is going to hang together. There's that negative charge. And this is going to increase the number of hydroxide ions in the water, and that satisfies our definition of a base. You will also hear the word alkali or alkaline used to describe a base. It is important to know both of these words as well. So if a solution is referred to as an alkaline solution, then I know as a chemist that they mean that that solution is basic in nature, or it's a base. So for the properties of bases, we want to be sure that you're comfortable with these. Bases taste bitter. Again, we're not going to taste any of the bases that we'll be using in the lab, but they do taste bitter, and they also are slippery. A very common base is just soap, regular soap. And I don't know if you've ever had your mouth washed out with soap. I hope you haven't had to have that experience. But it tastes bitter, and you know that soap is certainly fairly slippery. Just over there in the picture, Windex, which has ammonia in it, drain cleaners, that type of thing, a lot of those are bases. Bases are every bit as dangerous as acids. A lot of 8th graders come in and they know an acid can be harmful, but for some reason they think, well, maybe bases don't hurt you. They absolutely can hurt you. They are corrosive. Many of them are poisonous as well. And this got cut off just a little bit here. When we combine a base with an indicator. Remember our indicators, lots of chemicals that simply change color in the presence of an acid or a base. The bromothiamyl blue is not real exciting. If you put a base in bromothiamyl blue, it becomes a lighter blue. That's about it. So it's not super exciting. If we get litmus paper, and we get red litmus paper, and we put a base on it, or in the picture down here, they're actually dipping the red litmus paper into the base, it will turn blue. And so kids get sick of my saying this, but I have lots of kids that struggle to remember this. So I always tell them, bases turn blue, bases turn blue, bases turn red litmus blue, and I make them say it until they're sick of it. Bases turn blue, bases turn blue, bases turn red litmus blue. If you can get that in your brain, then you can automatically figure out that acids are going to turn blue litmus red. So when you get the test, just write down bases turn blue, bases turn blue, bases turn red litmus blue. Get that written down, and you can figure out the opposite is going on for the acid. All right, we do want to talk a little bit about the fact that acids and bases can be classified as being either strong or weak. When we talk about a strong acid or a strong base, what we mean by that is that almost all, very close to 100%, but almost all of the molecules in that particular compound break apart, and the word we use in chemistry is dissociate. So almost all of those compounds break apart in the water to create either the hydronium or the hydroxide ion. So hydronium ion if it's an acid, hydroxide ions if it is a base. So examples of some strong acids would be sulfuric, nitric, and hydrochloric. So I know as a chemist when I have that in water that I have an extremely high percentage of those ions is there and available from the dissociation of the compound. A weak acid or base, I don't know an exact percent, guys. You could easily look this up, but that simply means that not as many of those molecules have dissociated to form the ions. So you have a much smaller percent that is actually broken apart in the water to create the ions. And so some examples of some weak acids would be acetic acid. The common name for acetic acid is just vinegar. Citric acid, again, citric acid is a type of acid found in lemons and oranges, and even carbonic acid. So those are considered to be weak acids. I do want to make sure you understand that even a weak acid can be very harmful to you. One important chemical reaction to talk about with acids and bases is called a neutralization reaction. Again, this is a little simulation that won't show up, but you can look at it. And so I ask kids the questions about what happens when we add an acid and base together. What do you think happens? And so you notice over here we've got hydrochloric acid. There's the HCl represented right here. And we're going to combine it with NaOH. And there's just the hydrochloric. So the question is, what happens when you combine those two things together? And when you combine an acid and a base together, you do end up with a special kind of reaction called a neutralization reaction. So I'll show you what that looks like. Okay, so I want you to get this down in your notes. Put neutralization reaction as your key term on the left. And that is just the reaction of an acid and a base to form a neutral solution of water and a salt. So you end up with a solution that is not an acid, not a base. It's considered to be neutral. Notice that it says a salt. You do not always end up with table salt, which is NaCl. Now in this example right here, equation, you do end up with just NaCl. We've started with hydrochloric acid right here. We're adding the base, sodium hydroxide, and you notice we do end up with table salt and water. But if we started with a different base, if we started with magnesium hydroxide, then we would still form a salt. It would be magnesium chloride, which is still considered in chemistry to be a type of salt, and you always end up with water. I just want to point out that the definition says you end up with a salt and water. I have a lot of kids that think that means you always make table salt. The word salt in chemistry has a specific definition, which you'll learn more about in high school. But the point of this is that when you combine the acid and the base, they neutralize each other in such a way that you end up with a neutral solution. If you have ever had an upset tummy and it's been heartburn, you've had that wonderful experience where you kind of burp and it kind of feels like you're about to throw up, but then you sort of swallow it back down. It burns. It hurts. Well, yeah, it does. What you're doing is you're getting some, hydrochloric acid, stomach acid, and it's decided that it wants to sort of pop up a little bit. You're like, oh no, and so you swallow it back down. If you go to the nurse or something, I don't think she can give this to you anymore, but they used to be able to give you Tums or Mylanta or something like that. Well, all of these types of medications here are bases. And I think a lot of them use either calcium hydroxide or magnesium hydroxide. I think I've seen a few other things, but they're bases. And the whole point is that they're taking the stomach acid, they're giving you a base as your medication, And so it is neutralizing the stomach acid and hopefully making you feel a little bit better, making your tummy feel a little better. On the bottom here, you notice that we have one of our lovely little TCAP alerts. And this is another one that drives me a little bit nuts. But I have to tell you this. I want you to write it down. I want you to be sure you're ready for the TCAP. According to the TCAP people who make the test, if you have a neutral solution and you put a little bit of that on litmus paper, the litmus paper will turn purple. I've never seen it. I just have not seen it. Miss Pearson, who's new to us this year and taught high school chemistry at Gate City High School, she has never seen it. And when we go to lab this week, hopefully get you in there on Friday, I'm going to encourage you, go ahead and try this. I have not personally seen it. However, we know that the TCAP people do ask you questions about it. Again, bases turn blue, bases turn blue, bases turn red litmus blue, acids turn blue litmus paper red, and according to them, if you have a neutral solution, it turns litmus paper purple. I know it for the TCAP test. It certainly may be true. I'm not saying that at all. Maybe it is true. I've never seen it. So I'm not exactly sure what they're referring to here. But I'll encourage you again, try it when we're in lab. You'll be working with some different solutions. You'll certainly have the litmus paper right in front of you. And maybe you can turn it purple. And we'll all run over and look at it. Okay, guys, I think those are the basic notes that I want you to have. So what I want you to do next is I'm actually going to have you turn to this chapter on acids and bases. Now, I think some of you may have already done some work on this chapter for your iWork contract, and that's great. But I want you to have an opportunity. I've kind of gone over it in my words. I need you now to read the section on acids and bases in your textbook. Read it over thoroughly. Add any notes to your Cornell notes that you would like to. And again, if you have extra time, you're welcome to work on the iWork contract if you have not finished that. But when I see you tomorrow, we have a lot to do. We'll try to get those boats tested. And I'll show you a few of these video clips, and we'll talk a little bit, see if you have any questions specific to acids and bases. All right. Bye.